Hey everyone, welcome to today's lesson. Today is lesson 4, and we will be building a document ingest and semantic search agent, which essentially just parses a PDF doc, chunks it, embeds it, and makes it instantly searchable. Um, so basically, you're going to be learning how to turn any local PDF document file into a searchable knowledge base. We'll be extracting the text and parsing it using Node.js. We'll be implementing some chunking strategies for long documents, and we'll be generating vector embeddings with the OpenAI or Ollama, and we'll be storing everything for instant retrieval augmented generation for RAG, okay? So let's go ahead and get started. The first thing we need to do, I've already done it. You need to use npm and install mammoth and UUID. And then you need to install pdf-parse, but it has to be at types because it's TypeScript, okay? So make sure you follow these commands that I have highlighted here. And then what we're going to do after that is we're going to go ahead and make the embedding helper. I actually already just did that, which is right here. So when I upload, this will be available in the description of the course. You'll have access to the updated repo, and you'll see the embed text, the embed text.ts for the embedding helper. Okay. So this is already here, and then we'll be importing this, and we will be using it where we implement our ingest agent. So let's go ahead and start that now. We're going to go in the tools, and then we will create our new agent here. We can call this one Doc-Ingest-Path, I guess. Okay, so let's go ahead and import everything. Let's do it as SFS. There we go. We also import path. We need to import that. We need to import add doc. Okay, this is the add doc from the vector store. You will be just importing that so you can add the documents to the vector store. And then we'll be importing the new embed text. Oops, I spelled this wrong. There we go. And then is anything missing? We have tool descriptor, add doc. You know what? I forgot to import. There we go. Okay, so now I think it's the schemas. Let me check. Yeah, schemas. Okay, so now we're going to go ahead and we will build out the input and output schemas. Okay, so let's go ahead and do this. Okay. So here we provide the path to the file, which embedding model we need to use, and then the size of the chunk of each size. So let's go ahead and do that. This is not right. Well, it's kind of right. I have to add a default. There we go. Okay, so here, let's do chunk size. And let's see, we want for each embedding, we want the minimum. Oops. Okay, so we want the minimum to be, let's do 100. And then the max, let's do 4,000. And let's make the default 800. Okay. All right, so next is what the agent will be returning, the doc ID, the total number of tokens, and the chunk count and the status. So let's go ahead and do that. Agent returns doc ID, total tokens, chunk count, and status. Okay. Let's do like this. Let's change this here. Tokens, chunks. Whoops, no. Chunks. And then status. What we need to do for that is the operational result, which can be done like, yeah, what we can do is added and then failed. There we go. Okay, actually we don't need to. Okay, so next, let's see here. Let's go back to my notes. Next, we need the descriptor. So for that, we were going to do like this. Tool descriptor. This tells the framework how to list and validate the tool. Okay. We have tool ID, name, description, version, input schema, output schema, tags. Okay, this is everything we need, but it's not ideally correct. So we can match our current naming conventions. We will use ingest path dot v1. Okay. For the name, you can use that, but let's just make it. Let's do like this. Document-Ingest-Path, description. Okay, I guess this is sufficient. That'll work. And then for the tags, we need rag. That's there. we don't need vector, but we do need PDF. We also need docs. And then we need file system. And then we can use, I guess AI will be sufficient. You can use these tags for now. You can obviously modify this, set it up accordingly, however you see fit. Okay, so I think next we have the handler, but let me confirm. So yeah, we did the descriptor. Now we have the handler. Okay, cool. All right, so let's build out the handler, and this is going to be the main logic, okay? Which is the main logic, okay? This will also be async. Put schema. Okay, this is correct. This is all wrong. All right, so what we need to do is we need to read the file from disk, okay? And then use path.resolve to make sure we get the absolute path. And this will avoid traversal bugs, right? So let's go ahead and do that. It's actually got to be file path. Yeah, we imported path. Okay. So let's go ahead and keep going. And what this will do here is it will read the whole file into a buffer, right? So let's just do like, we can do like this, await file system, read file, and then we can do like that, and we do not need to include this. Okay. Let's see here. All right, so we need to choose the parser. Let's do and then we will get file extension, make sure it's lowercase. That's maybe, okay, not too lowercase, split and pop. There we go. Actually, let's add the operator and then bingo. Okay, so all right, so next we will we have to, if PDF, I guess for this we can use an if statement. So like basically if PDF dynamically import, and you have to, the reason for the dynamically import PDF parse to extract all text. If you don't dynamically import them, because I'm sure you're going to be wondering why we not import this on the top, and that's because of the E5 module rules with Node.js. So since I don't have it set up like that, and we're using imports at the top, you have to dynamically import it, right? So yeah, so if you don't do that and you do everything on the top, you're going to run into a couple bugs, and you're going to have to either change your package.json and your tfconfig.json to align with the E5, or you can just dynamically import it and you can skip all that and you're not going to have any issues. So for that, we're just going to do it like this. If you want to change it to however you have your project set up, you're more than welcome to, but for the sake of it, this is how we're going to do it. If okay. So here we will do if docs we'll import mammoth instead, extract all text, okay? And for that, we can use else if statement. And this is not really 100% correct. Actually, let's just go back. Let's just, okay. No. So here we will use raw text. And then else we will throw error. So error, and for this it could just be like, I guess, unsupported file type sufficient. And definitely no caps there. Okay. Okay, so now let's. Okay, so here we will double check if the file is empty after the extraction. Okay, so for that we can just say double check if the file is empty after extraction. Fail early. If it is, okay, yeah, that's fine. So if we have to trim it, so for that we do raw text dot trim, and then we throw error. So then we can just throw new error, and then we have a typo here. There we go. And then let's actually illustrate a little bit more here. So let's put like document contain no extractable text, right? It makes more sense. Okay, so now we will chunk the extracted text. So let's go ahead and let each chunk. Okay. All right, so we have to generate a new doc. You do UUID. So for that, we can just do const ID, and then oops, I had a typo here. Okay, so okay, so we are dynamically importing it. Okay, so what we will do here is and then we'll loop it. So for this, we will loop through the text and break it into n slices. Okay. So for that's not good. No. Well, I can just do like this. We need to push. So actually, we do. This is wrong. Let's do chunks. Yeah, that looks better. Dot push raw. Okay, this works. Okay, so now we will let the total tokens, okay, assign to 0, and then what we do is for each chunk we're going to be generate we're going to be generating a embedding vector and save to vector store. Okay, so for this we will actually this is all right. This works. Okay, so let's go ahead and save this, and then let's go ahead and open Postman. Go ahead and then we have to, before we get there, let's okay, so we need to, next we just have to set everything up in the server, and then we should be done. So let's go ahead and do that now, and then we should be able to run our server, and then we're going to be good. So let's go to our server, and then let's import the new Doc-Ingest-Path tool. So we will do import Doc-Ingest-Path handler as this is correct. Okay, so yeah, you always have to double check this code completion, because it's not always accurate, and I don't use it as much as I'd love to, but it does help get things done a lot quicker at times, I will say that. Okay, that will work. All right, so let's go ahead and run dev. You can just use npm run dev or yarn dev. I have a tendency to use yarn, but doesn't matter. So I have the document already downloaded. The document that I'm using is this here. It's a big old movie script. Well, it's got let's see, it's got 100 pages. Okay, I have no freaking idea who Bookworm is. It was written by Toby Harvard, so I'm not affiliated with them. I just went on Google and Googled give me a movie script PDF, and I downloaded the first thing I found. Okay, so we're gonna go ahead and let's delete this vector store here so we can start afresh. Okay, and then let's go ahead and go to the notes. So this is how we'll be ingesting the document. And then we will, I got to go back to my workspace. Hang on here. YouTube course, here it is. Okay, so let's create a new post. And then let's go ahead and do it. So it created the vector store. However, it failed to send a success message. So I will fix that, and when I update it, I mean, it's really not important at this point because you got the point on how to use everything. And I want to make these courses as short as possible. So I will add a return with success. That way, when you do have a success when doing this, you get a success instead of just a hang up, right? Um, but anyways, so now that the vector store is there, and for the sake of it, I'll do it again so you see that it works. I'm going to delete the vector store. We'll go ahead and we will send it. And then as you can see, the vector store is there and we have the bookworm here. Okay. So from there, we will go ahead and we'll run the semantic search feature, and let's go ahead and find something in here. Let's go to page, uh, let's go to page 73, and let's put this. I just let him take everything. I gave it to him on a silver platter, like you said. Have no idea what they're talking about, but anyways, let's go ahead and do the semantic search like that. Let me go ahead and add it to the query here. Okay, let's go ahead and put everything on a single line so there's no issues when I copy and paste it. And then let's go ahead and create a new request. And let's go ahead and check the body. And let's go ahead and test this. And here it is. So seems we have a problem here. This line does not appear in the provided context. So how we are going to solve this? Let's try it again. For the sake of it, let's just do, I just let him take everything. Okay, so we have an issue here. I am going to have to do some debugging. So instead of wasting your time while I figure out the cause of this, what I'm going to do is I'm going to find the issue, and then I am going to come back to this video, tell you what the issue was and how I fixed it, and then I will be able to wrap up this video, and then I will send a new test, and then we should be done. Okay, so I will be back, and well, obviously you'll just see the you'll just see the continuation from here, so I really don't need to tell you I'm coming back, but I'm coming back. Okay. Hey everyone, so I made a ton of improvements. Because this is a boilerplate, there was really not much logic in the rag search and the add doc and the vector store, so I had to make changes across, resolve some type errors and whatnot. There was a bunch of changes that I made, but you can go you can I actually I'm going to be updating this issue also in the main repo for the boilerplate. That way, these changes don't have to be addressed later on. You can just stack onto this and just make improvements to it. But anyways, also there was another issue with one of the documents. The text couldn't have been extracted from it because they were images inside. Uh, so I mean, it was a couple of issues, but whatever. I think I got everything working now. So let's go ahead and let's just delete this, and then let's go ahead and let's start all over here. Um, I'm gonna go back to the document. I tried to use the Venom movie script, but the Venom movie script was not working. So I went back to the Bookworm movie script, and at least the text can be extracted. But from the other movie script I tested when I got off of this video, it was, as you can see here, I'll show you. You have to use like OCR for this. I mean, I could do another lesson for this. It's not going to be in this one, but you have to extract this using OCR. There's several ways of doing it, but this entire script is basically scanned. So anyways, let me, uh, so let's do like this. Why did, oops, so it says that the screenplay by Toby Harvard appears to be centered around a young girl named Mildred who is keen on capturing a mysterious black cat. So I'm not going to read the whole thing. This is a good starting point. It's not perfect. So currently, right now, if you want to make improvements to this, I would start here. Um, the way that documents are being ingested, okay? I would change this whole input schema. So like I'm chunking the documents, right, and breaking them up, but there are different ways you can go about doing it depending on the requirements for your searches, right? So if you need to find specific text within those searches, then I would not even chunk it like this. For that, what I would do is I would refactor this API to actually call OpenAI to summarize and make a title for each chunk. That way, when you're doing your search, you can do like that. Also, I would make it so it returns a similarity score. That way you can use the highest similarity score when you're sending it over to your AI to send a response. So this doesn't do any of that, right? So this is just essentially an agent that does nothing more than chunks everything and does a search on it. So this is not really that advanced, but this is a good starting point, and then you can just build off this and essentially craft it into what you want it to be. So if you have any questions, just let me know, and I'm going to go ahead and update both the main repo, and I will also update the course repo with all these changes that I've made. And then yeah, so good luck, and anything you want to learn, just leave in the comments and I'll do my best to do it. Okay, bye. Hey everyone, so I forgot to add that this agent flow here is really not designed for 100-page documents like what I was using, right? Um, Essentially, you would need to use another method for that. So if you want to use this and you want it to be reliable, my recommendation is to um, parse the document, or um, at least break up a document before you call this endpoint, right? And then feed each one like that. That is the way I would go about using this. I would say maybe I would cap it at around 5 to 10 pages per document, right? Um, what I can do is I can build another agent that automates this and breaks everything up and then feeds it to this agent. Um, there are several ways to go about doing it. I have another agent framework called Agent Smith, like from the like from the Matrix. So basically, this agent framework is a little bit different. It's a router. It basically routes the inputs to the appropriate agent, right? So it's really designed for automation. So like if you are um, trying to automate things and you need the router to determine which what like if you're sending an input to the endpoint, right, to the base endpoint, and the endpoint is a string of text, but that string of text can have many different usage for it, right? Maybe it has attachments, maybe it doesn't have attachments. um, Maybe the text, the customer, for example, looks angry, so you have an agent that deals with angry customers. You have an agent that deals with document attachments, things like that. So I can actually build it in that and show you how that agent framework works. And when you send in the document there, it can actually break up the document. And then once it breaks it up, it sends each document to this agent, and then it will store it, and then that way when you run your searches it'll be far more accurate. That's one way to go about doing it. So if you want me to do that at any time in the future, I'll definitely do that. Or I can also add another agent here that does that. So I mean, I could do it both ways. So anyways, I just thought to bring that up, and you can leave your thoughts in the comments. All right.